Okay, guys, we'll move to the question number 3. That is to find the greatest common divisor of 1305 and 101, and it is specifically asks us to use the Euclidean algorithm. Okay, first of all, we'll identify what is this greatest common divisor and why it is specifically they ask us to use the Euclidean algorithm and what is this Euclidean algorithm. Okay, greatest common divisor, I will tell it is like this way. Just imagine where we'll take a simple question like 18 and 12 to find out what is the GCD, that means greatest common divisor. Greatest common divisor is the largest common divisor which can divide both numbers. If you want to find out a greatest common divisor of two numbers, that means it is the largest number that you can divide both of them. Okay, so if it is a simple problem like this way, we'll find out what are the divisors of this 18 first. That means which numbers that you can divide 18 without having a remainder. Okay, so you can divide it by 1. Okay, then you can divide by 2. Also you can divide by 3. You divide by 4? No. 5? No. 6? Yeah, you can divide. And 7, 8? No. Then after that, yeah, 9 you can divide. Then you can divide by 18. Okay, what about 12? 12 also 1 you can divide, and 2 and 3. What about 4? Yeah, 4. 5 can't, 6, yes. 7 can't, 8, 9, and after that 12. Okay, 12 divided by 12. So now these are the divisors of 18 and these are the divisors of 12. Okay, tell me what are the common divisors for these things. You can see 1 and 1 is there, 2 and 2 is there, 3 and 3 is there, and 6 also there. All the others are not common. So then what are the common divisors for this 18 and 12? The common divisors are 1, 2, 3, and 6. 1, 2, 3, and 6. Tell me what is the largest value. This 6 is the largest value. So we are writing 18, 12. The greatest common divisor of these two is what? 6. This is the way we are writing that one. So if it is a small number like this way, you can find out the divisors by factoring them, and after that you can find out what is the common divisors and find out what is the largest value. But this is valid for small numbers. Okay, but if it is a large number like this 1305, this method doesn't work well. Okay, you can do, but it will take more time. So the best method is called as the Euclidean algorithm. Okay, so we'll see what is this Euclidean algorithm and how do we use it to get the things. Okay, right. So I'll erase this thing. Now we are going to use the Euclidean algorithm. In the Euclidean algorithm, what we are doing is we are dividing this the largest value by the smaller value. Okay, now what is the larger value? Here 1005, that is the large value. What we are doing, we are dividing it by 1001, sorry, 101. Okay, and we are writing it in a particular pattern as a we are writing it as a division algorithm. So first write this largest number 1005, and then write this the second number 101. Now how many factors for this one? How many when we divide this one, we call this as the quotient, and how many divisions for this one? If we divide 1005 by 101, you can see for 130 there is 1. Okay, and then if you subtract 130 by 101, it is 29. So 295, there are two 101s, then 202, and 295. When we subtract 295 by 202, you are getting the remainder as 93. Now the remainder is 93. This is the first step. Okay, this is step number 1. The second step, what you are doing now, you are taking this 101 value to here and take this remainder to here and check how many 93 is for this 101. Okay, you can see now there are only one 93 for 101, and what is the remainder? 93 101, it is 8. Now the next step, you are taking this 93 to here and you are taking this 8 to here. 8, and how many 8s for 93? You can see it is 11, 88, and it is remainder is 5. And now take this 8 that is to here, and this 5 you have to take to here. How many 5s for 8? You can see it is 1 and 3 is there. Now this 5 you are taking to this side, 5, and you can see how many 5s, and you can take this 3 to here. 3, how many 3 is there? 1 3 and 2 is there. Then next step, you are taking this 3 to here. 3 equals how many 2's there? 1 and here 1, right? 2 and 2, right? Then you are taking this 2 to here. 2, then how many 1's for them? 1 into 2, right? 2, and the remainder is 0. Until you are getting up to this 0 at the end, you are continuing the process. After it is reaching this remainder as 0, what we are doing, what is the last remainder you have taken? That is the last divider you have taken. Okay, this is the last divider you have taken. This remainder is the divider here. Okay, last divider is 1. That last divider is called as the greatest common divisor. So what is our last divider? This is 1. You can either take from here or here. Okay, the same thing. Okay, this remainder becomes a divider here. So the the greatest common divisor of 1305 and 101, it is 1. Then 0, 5 and 101, it is 1. What do you mean by this 1? 1 means there are no common divisors for 1305 and 101. Okay, but anyway, therefore the greatest common divisor is 1. Okay, right. So in order to understand this more, I will give another question. Okay, we'll understand it by this way, and you can understand what is the pattern going on. So we want to find out we'll find out this one. Okay, 850 and 289, what is the greatest common divisor? Okay, what is the GCD value of that one? Okay, by using the Euclidean algorithm. Now we'll start by our method. First write the largest value 850 and the smallest value here. Okay, and now check with the how many remainders. Now you want to divide 850 by 289. There are no 3, right? Only 2. So you want to multiply by 2. If I take this as 290 into 2 is 580. 580, but since it is 289, it is 578. 578 and 22 for 600, 220 for 800, 200, so 22 to and 272, right? So we want to put 272 is the remainder here. Okay, 272. Okay, then 289 you are taking to this side, and 272. Okay, this remainder comes to here. Okay, there is the pattern. This remainder comes to here, right? And you know that there are how many? 1, and the remainder is 17, right? Now this 272 comes to here, and 17 comes to here. How many 17s there? It is like 1 and 16, right? 16. If we multiply the 17 by 16, it is directly comes to 272. So this becomes 0. So the what is the last remainder here? 17, and it is the last divisor. So the last divisor is 17. So our greatest common divisor of 850 and 289 is 70. Okay, this is the answer. Okay, I think you got the point of using finding greatest common divisor by using Euclidean algorithm.